So in this video, we're going to go through the entire spreadsheet example using our respective software. So we'll be jumping between this screen and our software and how to implement it. So just recall, our spreadsheet example was focused on a law firm trying to determine which of four spreadsheets would be best for their secretarial pool. Learning time depended on the individual secretary and the type of task. So again, that's our two blocking factors, secretary and our task. And our response is learning time, and our treatment factor is the spreadsheet A, B, C, and D. So in this example, we have T equal to 4. So our number of experimental units is 16. It is not T cubed because when we look here, we can see that we have 16. It's squared, 4 here, 4 here. And so the first thing that we want to try and look at is maybe our test of treatment effects. So does spreadsheet, this should probably be A, B, C, and D. I'll fix that on y'all's notes. So do these treatments, are they the same or do they differ? And we're going to get this Anova table. So let's jump over to our software to see how we calculate that. In JMP, to get our Anova table for the Latin square design, we go to Analyze, Fit Model. Our time is our Y. Our spreadsheet, secretary, and tasks are our model effects. Spreadsheet is our treatment, secretary and task are our blocks. We're going to run. We're going to get this output where we're going to scroll down. We have our Anova table down here. Again, to get the mean squared, you're going to right click, column, mean squared. So notice that we have a p-value of 0.0117. So we're going to reject the null where we're using an alpha of 0.005. And we're going to conclude that there are significant differences in the means of completion time for these four spreadsheets. Additionally, what we can also do is if a priority to doing your design, you had a thought of a specific contrast you want to look at, we can also do treatment contrasts for the Latin square. So let's look at that. So this should all look very, very similar to what we've seen before as contrasts. We have our L, which is our population contrast. It's going to be under our specific constraint where all of our C's have to sum up to 0. We can get our estimate, we can get our standard error. We can also do an F test on the contrast. This F is only valid if you're doing two-sided. We get our sums of squares contrast. Note that this shouldn't, I put a little 0 or O down here to hopefully not get confused between the sums of squares of your column, okay? Your MSE, and then if your null is, we're going to reject the null if our F observed is greater than our cutoff or if our p-value is less than our alpha, which is typically 0.05. So let's say we had an example. So spreadsheet A and B are from domestic companies and spreadsheet C and D are from foreign companies. It is interesting to look at if the average completion time using spreadsheets from the domestic company is different from these spreadsheets of the foreign company. So our hypothesis here is 1/2. One is A, B, C, D, A, B, C, D. Equivalently, we would want to look at it in terms of our contrasts. And so our L would be 1/2 alpha plus 1/2 A plus 1/2 of alpha B plus 1/2 of treatment C and D. Again, how we end up getting these is we look at our hypotheses here and we brought this term over here. And so that's where the minus signs comes in from. You could have also brought our A and B to this side It's more of a personal preference in this case, and we're just looking at there's a difference. So our L, we're going to estimate our L hat. We're going to estimate our sums of squared error for L hat. And we're going to get a sums of square contrasts of 0.09. We got a p-value of 0.379. And so with the p-value this large, we're going to fail to reject the null. That is, there's insufficient evidence that the mean completion time for spreadsheets produced by domestic companies differs from the mean completion for spreadsheets produced by foreign companies. So just like we did for testing if there was an effect, let's go look at this through how we would do this in software. For contrasts, especially for our example, we're going to go up, scroll to the right. We're going to go to our spreadsheets because that is our treatment. Click on the red arrow, contrasts. A and B were positive, C and D were negative. Click done. We can click here for more information where we get our L hat, our standard error. We get our T statistic and our p-value. We can also get our F statistic and our p-value. The last thing we want to look at and just mention is that you can also do maybe Fischer's LSD or Tukey's. We've done a lot of Tukey's up to this point, so I want to kind of bring back that there is another method other than just doing Tukey's. And so we can do Fischer's least significant difference comparison, which we have here. Recall that levels not connected by the same letter are significantly different. So A is significantly different from B, C, and D. For the Fischer's LSD, we're going to again come up here to the red arrow next to spreadsheets. Click it. We're going to go to student T because that's how you get the Fischer's comparison. And right down here you have your Fischer LSD.